So, the first combustion reaction you've of course seen many times before and is not exciting at all, but methane is what comes out of the burners, and there we have methane gas burning. Let me turn the gas down just a little bit so it quits blowing itself out, and there you go. That is methane reacting with oxygen and burning. If it doesn't burn cleanly, you don't get the products that we've predicted. You get actually sooty products. If we were to put a glass plate here, you would actually see there's black residue left behind, which is carbon that has been stripped of the hydrogen, or sometimes it's even hydrocarbons, where there's still hydrogen there, but it has not reacted cleanly with the oxygen to form the nice byproduct. And that's the other thing that I frequently try to emphasize about a Bunsen burner flame, is that you don't have smoke here. You're used to seeing flames with smoke where there's this smoky byproduct. But if you have really clean, really good, pure burning, you don't get smoke. And our byproducts are, as we've predicted, carbon dioxide and water vapor. And there are ways to test that. We're not going to do that right now, but we could try to trap the gases. And then you can test the carbon dioxide several ways. The water, you pretty much just have to watch water droplets condense, and you could maybe test that that is water and not something else. But the water is maybe a little bit harder to test. And most hydrocarbon combustions look like that. Of course, some hydrocarbon combustions are liquids or solids to begin with rather than gases to begin with, but even those still look like this when they burn. If they don't burn completely, you'll get the more yellowy flame, and you'll get more sooty flames, and you'll get more incomplete combustion byproducts. But that is what most hydrocarbon burnings look like. This, on the other hand, is magnesium, and this is, in addition to being a combustion reaction, also the next type of reaction we're going to talk about, which is a synthesis reaction. This is incredibly bright, and you should not look directly at it. It is actually putting off, in addition to bright light, UV light. But down here you can see the magnesium oxide and magnesium nitride byproducts. This one's burning so hot it actually forces the nitrogen in the air to burn, and you get the magnesium nitride there. Not in large quantities. Most of this is magnesium oxide. And you can get rid of the magnesium nitride simply by wetting it with water. And if you wet it with water, then you get the magnesium nitride will react, and you get ammonia and more magnesium oxide. Instead, you can turn all the nitride into oxide fairly simply. But that is that one. And you'll notice the product is very different with this particular reaction, and also that the product is very brittle. And that's actually common for the type of compound we formed here, which is an ionic compound, which is a more crystalline compound. Questions? I'm going to stop this before it runs out of memory and delete.